Hello everyone, my name is Jakub Wądołowski. As just mentioned, I work as a systems engineer at Cognifide, and today I'd like to tell you a story about content delivery. And I know that my talk is the very last thing between yourself and lunch, so I'll try to be as brief as possible. So over the last 8 years or so, I've been involved in multiple projects, and those projects were for large and small companies, and for companies from very different industries, so for automotive companies, for pharmaceutical companies, for financial institutions, etc. But the business you operate in doesn't really matter, in the sense that you're going to have a content delivery problem sooner or later. Most of those companies have been founded like 30 plus years ago. So the business at the very beginning was 100% offline. But then internet happened and they went online, and from a local business, they expanded across the globe. So let me show you an example. So this is a real example, by the way. So that particular client initially started as a UK-based business, and for that, like 10 years, they've been operating exclusively within the UK. But after a while, they expanded onto a few extra countries within Europe, and nowadays we are here. So we have like pretty much, they sell goods pretty much everywhere. And you have to find a way to deliver content across the globe. So yeah, that content delivery problem hits you, and you have to do something about that. So the first thing most people do is, okay, I have some sort of application, I've been online for quite a while, and I have to like manage or handle increased load. And that increased load typically means like thousands of requests a second. But is my application really ready to handle that increased load? Most likely you've built like a monolith of a kind, and you have to like either upscale it, or if you're lucky, you can horizontally scale it, and it's gonna work. The next thing that may come to your mind is, okay, so if I operate globally now, maybe I need to replicate my stack in different regions. Okay, so maybe for that particular example, if I had a business specifically within the UK, I had a UK data center, but now I operate in like Australia or United States, maybe I have to recreate my stack over there. But it's not cost-free, of course. If you have some sort of a stock and you sell goods online, most likely you'd like to keep that stock in sync. So like your customers will be frustrated if a product, a popular one in particular, is available for your US customers and is not available for your European customers because there's some sort of out of sync between these two data centers. Plus there's like licensing implication, maintenance implication, so it's not cost-free. From reliability perspective, that's definitely a good move, but from content delivery perspective, that's not necessarily a good idea. And what about performance? Even if you have multiple data centers, that may not be enough. Like we had a client, a US-based company, and they said at some point in time that having a single data center within the US is not really a viable option to deliver a decent performance within a single country. So even if you have a regional data center, that may not be enough. All right, so is there a better way to handle increased load and like global scale? Of course there's a better way. I wouldn't be standing here otherwise. So you may recognize those names or those brands. Every single name here offers some sort of content delivery service. So there are companies like Akamai, and Akamai has been around like, I don't know, 30 plus years probably, as that's the very first CDN on the market. But there are companies like Fastly or Cloudflare, which exclusively offers CDNs. But there are like companies like AWS or Google Cloud, and they also have some sort of CDN offering in their portfolio. All right, so what about CDNs in general? Just a quick audience poll. Who ever heard about CDN or worked with one or has some sort of relationship with CDN? All right, a few people, all right. So content delivery network is a fairly simple concept, and I'm gonna show you that in the next few slides. So first thing, is how the world look like when CDN is not involved. Like if your web application sits in Dublin and you have a user in Poznan, there's a request from Poznan to Dublin and you get some response back and that's it, nothing fancy. With CDN, there's something in between that CDN will sit as a sort of an interface or entry point to your application. And it's going to be distributed across the globe, so they have multiple points of presence, or like hundreds, thousands of servers, depending on the provider. But in this particular example, we have a user in Poznan. The closest CDN server will be in Copenhagen. That could be Frankfurt, Amsterdam, Warsaw, or even Poznan. So you go from Poznan to Copenhagen in this example, and then CDN will say, okay, I have no idea what you're asking for. Let me fetch that data from the actual application. So the request will be proxied. You get a response back. The CDN says, okay, I have a response from your application. I'm going to cache it in my data center, which is in Copenhagen here, and I'm going to send the response back to the client. So the subsequent request will stop in Copenhagen. You don't have to go through the entire continent or across continents to get some data. And that's cool. So as I just said, CDN is nothing more, at least at the very basic level, it's nothing more than a reverse caching proxy. So they proxy traffic through their infrastructure, and then they can cache responses from your application. But there's much more than that. So you can do HTTP routing at CDN level. So if you have different applications or set of different applications which handle different kind of traffic. So let's say you have an application which is responsible for assets, or you have a set of APIs, you have your content rendering application. You can use a single domain and route traffic between those applications at CDN level, which is quite handy if you have like multi-continent presence. So if your API is within Europe and in United States, you can say, okay, if the user comes from United States, pick the API which is the closest to that particular user. Having a CDN in front allows you to control the full flow, which is, again, super important, as most likely your application is composed of new shiny stuff and some legacy applications, which may not necessarily be prepared for like caching capabilities or invalidation, or from security standpoint, that could be also quite handy. The VCL here stands for Varnish configuration language. This is an example of a software that you can use to control that flow. I'm going to show you a few snippets of that later on. The next thing that you can do at CDN level is Contin Assembly. ESI, which is edge-side include, that's a technology which is fairly old. It was like from late 90s. It was originally developed by Akamai, and that allows you to like fill in, like, it's super simple. You have some sort of a template with placeholders, and you fill in those placeholders. Nothing fancy. Again, there will be examples later on. Security, that's kind of popular topic on this conference. So since the CDN is the entry point to your application, you can use it as a security layer as well. So yeah, things like web application firewall or DDoS protection, that's also possible. Image optimization, another handy thing. If your application doesn't support modern web formats like WebP, or you'd like to downscale an image, rotate it, blur it, put some overlay on top or whatever, you can use CDN for that and completely forget about like managing assets internally. There's a lot of improvements that you get like pretty much for free when CDN is involved. So like if you'd like to use Brotli, which is a new compression algorithm, which is much more efficient than gzip, that's available. Your application doesn't support HTTP2, not a problem. Your CDN does, so you get HTTP2 for free. You'd like to try or measure the impact of TLS 1.3, it's available. Or maybe you'd like to assess the impact of BBR, which is a TCP congestion protocol for particular API, it's available as well. So yeah, a lot of improvements for free. And last but not least, the edge computing. That's a new shiny thing, which is which has started some time ago, but that's going to be huge in the upcoming years, as that allows you to attach some sort of bespoke logic to your CDN and distribute that across multiple locations. So you can like potentially render content directly on CDN servers, which is super, super, like from performance perspective, that's extremely handy, as like the round trip time between yourself and the closest edge server will be super short, and that edge server will generate the response for you directly. So yeah, pure benefit. All right, so when you put a CDN in front, some of you may have an impression that even if the CDN initially has been configured to act as a completely transparent proxy, there's no caching whatsoever, whatever comes in will be proxied back to your application and the response will be ignored, so it will pass through transparently back to the client. You get some sort of improvement that may look like a beating the speed of light. And some of you may like start to scratching your head and think like, okay, did that guy just lost his mind, or is he gonna to like reinvent some core physics principle? That's not true. I'm gonna show you how it looks. So we have yet another example here. Let's say that our user is in Portland, which is West Coast US, and we have a Dublin data center, which most likely is AWS, and the round trip time between them is like 600 milliseconds, which is significant. If we put CDN in the middle, in this particular case, there will be an edge server in Seattle, which is a couple hundred kilometers north from Portland. So the first connection will go from Portland to Seattle, and that's going to be fast, so 30 milliseconds. The connection from Seattle to Dublin will be like 400 milliseconds. And some of you may think, all right, 30 plus 400 is not 600. So where that number come from? So CDN edge servers are connected closely to the backbone of the internet, and they do care about optimal routes in terms of like BGP, in terms of peering. So there are high chances that connection from the CDN edge server to your data center will be faster than direct connection over the open internet. And of course, the subsequent connection will stop in Seattle, if the response was cacheable, of course. And you can expand this concept even further. So you can introduce like a second level of caching within the CDN network, which is may not sound like an obvious move, but it is really beneficial in terms of content delivery. So that 30 millisecond round trip time from the user to the edge server, plus 350 milliseconds between CDN servers, and that traffic stays within CDN network. Plus the connection from London here to Dublin, which is going to be fast, so like 10 milliseconds. So we get even further improvement by introducing yet another caching layer along the way. And it may sound fishy to you that it's not necessarily the case. So I'm going to show you an example from the actual production system. So this is the moment where we introduced that second level of caching. So the miss latency was reduced from like 200 milliseconds on average. That miss latency is the round trip time from CDN edge server to the application. And that vertical black bar is the moment we deployed that to production. So 200 milliseconds went down to 70 nearly instantly by having additional hop along the way, which again may not sound like an obvious improvement, but yeah, that was a huge thing. And this is what happened with Fibre Freeze. There was quite a few of them, not necessarily a huge amount of them, pretty like every dozen every couple of minutes, but since the moment we've introduced that, they nearly vanished. As we get like most of those Fibre Freeze were caused by like some sort of a timeout, like in between timeout or like connection timeout or any kind of timeout. All right, let's talk about routing a bit. So most people think about CDN this way. You have an application, there's a CDN in between. And maybe you're working on a new version of the application, which sits like close to or next to your old system. And in the ideal scenario, the switch will be like this. But that's not the case. I haven't seen a project which switches like the whole stack at once, like the big bang approach. This is a dream that will never come true. In real life, it's like this. So you have a bunch of legacy systems, you have your new shiny technology as well, plus maybe you have some like shared asset system. And you have to route traffic between those systems. Like, okay, when you introduce that new system, maybe it's gonna be responsible for 5 to 10% of the traffic. It's not gonna be the only application running within that particular stack. So here's an example, a few snippets from the VCL, the Varnish configuration language. So Varnish itself is like a generic software. This is a caching proxy. And it's very often used as a technology behind the CDN. There's at least a few CDN providers that use Varnish for the actual caching and routing and all the other bits. So Varnish is nothing more than a big state machine. You have a few states, like, okay, I've received the request. Okay, I'm trying to look it up in the cache. I'm trying to send the request to the origin. I've received the response, etc. So there's a lot of points that you can plug your custom logic. So here's a few examples that VCL receive. At the very top is the very first state of the very first stage of request processing. As you can see, it's fairly straightforward. Like, this is a simple if statement with, okay, if that's true, then do that, which is like, okay, if it is a snippet request, go to this particular backend. The VCL fetch is happens when you get a response from your origin, so you can like clean up some headers. For example, that vary asterisk is extremely dangerous in terms of caching. So you can clean it up. And VCL deliver is the last stage of processing, so you can clean some headers that you don't need or browsers don't care generally. All right, so let's talk about Contin Assembly. I've introduced edge side includes before, and this is the deep dive into that. So in most cases, your website looks like this, or your pages looks like this. You have some content in between, there's navigation at the top, and some footer at the bottom. Like markup-wise, you have a bunch of divs at the bottom and at the top of the page, and those sections stay the same across various resources. So if this is product A, the header and footer will look the same. For product B, it's going to be exactly the same situation. So yeah. And the pattern, of course, repeats for remaining resources. So you can use ESI to reduce amount of time to render that and reuse some pieces of markup. So here you can, instead of those divs, you can use ESI HTML-like markup, which is, again, rather simple. So ESI include and some path to the resource. So from request processing perspective, this is how it looks. Again, we get a homepage request, CDN cache is empty, we proxy it back to the application replies, but this time, instead of full HTML, we have some sort of a template. So ESI include at the top, ESI include at the bottom, and some generic body. When CDN receives that, it says, oh, there's an ESI markup inside, so let me fetch those objects. So we fetch the navigation, we fetch the footer, and we put those divs I've mentioned before into ESI placeholders, and we serve the response back. When another request comes in, for example, for products HTML, you don't have to fetch those navigation and footer again, as they've been just cached, so they're already available there, and you can straight serve the response back to the client straight away. Of course, the concept applies also to things that are not cacheable, which I'm going to discuss in a second. So some of you may say, okay, caching is nice, but my application is not that simple. I have dynamic content, like pretty much every page is personalized. I have like hundreds of different groups of users. And like if you're a woman over 30, you see X, but if you're a man over 40, you see something different. So that's not that simple. Or maybe you need to authenticate to see anything. Like the website for the anonymous users is one thing, but there are different users who need to authenticate to see anything. Or maybe you use A/B testing heavily, and like for a particular group of users, you'd like to measure the impact of, for example, different layout. So is this really something that stops you from using caches? Not necessarily. There are techniques that you can use to cache such content. So even if you're like authenticated user, or I don't know, if you have hundreds of different personal target groups, you can cache that content as well. But it requires a slight change in your mindset. There's a statement that I remembered from one of the conferences where Fastly CTO said there's no such thing as dynamic content. Everything is static until it changes. And it's kind of true. In a sense, like, okay, even if your content is valid for a second, it is valid for a second, so you can cache it for a second. Or how often your homepage changes? Like, does it happen every 5 minutes, or does it happen every few days? So it requires a bit different thinking sometimes, but with rich invalidation APIs, you can actually leverage the cache and react on changes quickly. So imagine if you're like a newspaper. Like if your homepage is being cached for a day, you're not gonna be a newspaper for a long time. That's like, you have to publish frequently. So, but you can cache that homepage for like an hour, and if there's an important update, you can invalidate that object within milliseconds globally. Like there are APIs right now, in not every CDN provider, but most of them provide some sort of functionality that you can invalidate particular objects on quite granular basis within milliseconds globally, which is awesome. All right, speaking of caching, caching is actually, like, the longer I work with that, the more thing I discover. So I gave an internal talk about that in Cognifide, but I'll show you just two examples from like, speaking of caching specifically. So we have a prio to redirect here. There's a bunch of headers included, and one of them is cache control, no cache, no store, must revalidate. That's the value you're gonna see whenever you Google how to prevent caching. That's gonna be the top result. But let's break it down a bit. So the first thing is no cache. No cache is like naturally it looks like, okay, no cache means no caching, but that's not true. When no cache is present, you can actually cache that. Your browser will cache that when no cache is present. The naming convention is slightly misleading because cache control is both request and response header. We're gonna focus on response headers here, but no cache doesn't mean no cache, literally. It means you can cache it, but please revalidate. Make sure you have the latest copy before you use that cached object. The next thing is no store. No store is, this is the natural approach, and no store means no store. Do not store that object within cache. Must revalidate implies caching, as if you're about to revalidate something that has to be cached before. So the response, no cache, no store, must revalidate, says you can cache it, don't cache it, you can cache it, which is like completely wrong. Like, thankfully, all the implementations that I'm aware of, they respect, or the no store takes precedence, and that's it. So those remaining values will be ignored entirely. But like, I've seen that in so many places, and that's just wrong. Right, another thing, another caching mistake. So again, some HTTP response here, this time to 100. And we have cache control, which looks like this. Public no cache equals set cookie and max age 180 seconds. The max age and public, those are valid values. The no cache, as I've just said, doesn't mean that you're not caching stuff. And that set cookie looks kind of weird. So if you Google it up, you will discover that there was an email thread a couple years ago. And a man called Roy, he said that, you know what? I propose such a functionality that whenever that set cookie or any kind of value here is associated to no cache key, such response shouldn't be cached if both cache control no cache equals some value and that value, which is a header name, are present. And some of you may ask, well, who's Roy? And who gave him permission to put misleading opinions or misleading advices online? So, by the way, that no cache set cookie has never been implemented. That was just a proposal. People still, like, if you Google it up or query Stack Overflow with that particular string, you'll get some results. People recommend, okay, if you have set cookies, just set it. Nothing, literally nothing, will respect that. But people still put it online because they read it somewhere. Okay, so back to Roy. Who is Roy? Roy is actually one of co-creators of HTTP 1.1. The gentleman is called Roy Fielding, and he was like responsible for the original design of HTTP 1.1. So please do not use that ever. It doesn't make any sense. You're just wasting energy. All right. So since I had just 30 minutes and pretty much every bullet that I introduced at the very beginning, I mean, image optimization, WAF, edge computing, content assembly, etc., those topics deserve a separate talk. That was kind of brief, but the CDN or content delivery in general is an extremely broad topic with a lot of interesting aspects. So if you have any sort of questions about that, I'm here to help. That's all I had. Thank you. Do we have any questions?
I think we have time to pick one.
All right.
At least. Come on. Question.
There's plenty of 1 minute left.
In the meantime, I would like to thank you with this very little Poznan gift. Oh, yeah.
There's one over there.
Hello. So, which CDN platform do you recommend?
I'm a bit biased, as I've been working with Fastly closely for the last 6 years or so, and I do like the service a lot. But I've been working with other CDN providers as well. But Fastly is definitely my favorite.
Can you compare it to Cloudflare, for example?
Feature-wise, they're nearly the same. They offer similar functionalities, but they implemented them in a slightly different manner. So, for example, ESIs are not available on Cloudflare, but the edge computing offering Cloudflare has is definitely much more mature than what's available in Fastly. So it depends on the use case, but feature-wise, they're really, really similar.
Okay, thanks.
All right. Thank you so much.